To take the derivative of secant inverse of x, we can let secant inverse of x equal y and rewrite this equation as secant of y is equal to x by swapping the inputs and outputs and getting rid of the inverse symbol. And now this equation, we can take the derivative of this equation, both sides of this equation with respect to x or with respect to y, in this case with respect to x. Doing so, we get that dx is equal to 1. The derivative of secant y, well, we've seen that in a different video, the derivative of secant is secant tangent. So from here, we'd have to use the chain rule, so times the derivative of the inside of secant, which is y, so dy dx, since we're differentiating with respect to x. Now solving for dy dx, we can divide both sides of this equation by secant y tangent y, like this. But what is secant y? Well, that was x. And what is tangent of y? Well, using this identity, we can see that tangent of y is equal to the square root of secant squared minus 1. And again, secant is x, so this is just the same thing as x squared minus 1. And so this is the answer. So we can say that the derivative of secant inverse of x is equal to 1 divided by x times the square root of x minus 1. Instead of differentiating with respect to x, we can differentiate with respect to y. That way we don't have to use the chain rule. So doing so, the derivative of secant of y with respect to y is again secant y tangent y. And again, what is secant y? Well, that's x. What is tangent y? Well, that's the square root of x squared minus 1. Because remember, tangent of y is the square root of secant squared y minus 1, and secant of y is x. So tangent y is the square root of x squared minus 1. So we get that dx dy is equal to x square root of x squared minus 1. But we don't want dx dy, we want dy dx. So we can reciprocate both sides of this equation and get dy dx is equal to 1 divided by the absolute value of x times the square root of x squared minus 1. So that's another way to find the derivative of secant inverse of x. The derivative of secant inverse of x is equal to 1 divided by the absolute value of x times x squared, the square root of x squared minus 1, just as we figured out over here, differentiating with respect to x. Another way to do this is to use this inverse function theorem for derivatives, setting up the same equation, secant of x, secant inverse of x is equal to y, solving for x, we get that secant of y is equal to x, but we also know that if f inverse of x is equal to secant inverse of x, that f of x is equal to secant of x, the original function. But we don't want f of x, we want f of y to find f prime of y based off of this relationship. So f of y is equal to secant of y. Just plug in a y instead of an x. And now we can take the derivative f prime of y, so the derivative of secant of y, well again, that's secant tangent. Well, again, what is secant y? Well, that's just x. And what is tangent y? Well, that's just the square root of x squared minus 1. So again, we can say that the derivative of secant inverse of x is 1 divided by the absolute value of x times the square root of x squared minus 1, based off of this formula, 1 divided by f prime of y. And f prime of y was this. So here are 3 different ways to solve for the derivative of secant inverse of x.